This video is going to discuss doing delta to Y and Y to delta conversions. Alright. As you can see here, we have a circuit, and in this circuit, looks kind of complex. We actually have a Y circuit superimposed on a delta circuit. So this is the delta circuit, where we have three resistors. In this case, they're labeled A, B, and C. And we see these a lot, especially in three-phase AC systems, but we're going to study them here. And so this is a delta type circuit, so it has three terminals. It has the A terminal up here, the B terminal, and the C terminal. And we can convert from a delta sort of shape into more of a series kind of shape here. So we can convert this delta back into a Y type of connection. Now, to do that, you can see that we've got these resistors labeled 1, 2, 3 for the Y, and A, B, C for the delta. And so if you look over here, I kind of have all these equations here, and you got A's and B's and 1's and 2's and 3's and everything all over the place. So I'm going to show you how, don't get caught up on where does the 1, 2, or 3 or A, B, C go. I'm going to show you, look at the circuit and it falls into place. Alright, so to start with here though, let's take a look at a simple parallel circuit here. So we have a simple circuit here with R1 in parallel with R2. So we know that the parallel combination in this parallel combination, we know that we could replace these two parallel resistors with a single resistor, call it R parallel, where R parallel here is 1 over R1 plus 1 over R2. Now, if we do a little bit of algebra on this and get a common denominator, right, we could multiply R2 and R1. So we would get R1 over R1 on this side and R2 over R2 on this side. And then we rearrange this and we end up with a special case of parallel resistors. If you just have two resistors in parallel, you end up with R1 times R2 divided by R1 plus R2. Alright, and so for these parallel resistors, you see that you take the R1, this resistor, and you take the R2, this resistor here, and you multiply them, and then divide them by the sum of them. Well, it's very interesting. If you're going from a delta to a Y, notice here that we have three resistors, and in the denominator, to go from the delta, which is basically the parallel circuit, into the Y, which is kind of a series connection, to go to that, all you do in the denominator is you add those three resistors. Notice it doesn't matter which of the three resistors you're trying to determine, whether it's R1, R2, or R3, the denominator is the same. So this denominator is exactly the same for doing a delta to Y conversion. That denominator does not change. The only thing that changes is the numerator, which two that you multiply it by. Alright? And that's actually really, really easy too. Notice here at R1, you're multiplying it by the two resistors right beside it. So almost like what we were doing down here, where we had, okay, here was this resistor, here's this resistor, and we're going to replace them with a single one, so we're multiplying R1 times R2. Well, that's practically what we're doing there. Up here, we're taking the two that are touching, or that are like touching at this point and coming out. And so the one that's going to be, we're going to replace those two with, those are the two resistors, RB and RC in this case, that we multiply to get R1. So it doesn't matter, well, is this a 1 or an A or B? What you need to do is simply look at the physics. Okay, if you look at the physics and say, okay, when I want to bid this value of resistance, I use these two resistors. And if I want to get this resistor, I use these two. And if I want to get this resistor, I use these two, and the denominator does not change. All right, so it's very, very simple. Now on the Y to delta, okay, if we wanted to go the opposite direction, all right, what we're going to do is we're going to take, and we're looking at the Y's, okay, so we're looking at the Y connections here, and we're basically just going to take every single one of these. So if we're going to do any of them, it doesn't matter, the numerator doesn't change. So see, up here, delta the Y, the denominator stays the same. But if we're doing a Y to delta, and I didn't put them all on here, but if we're doing a Y to delta, the numerator stays the same. All right, and the numerator is simply, you take the Y, which are your three resistors, so you're going to have R1 times R2 plus R1 times R3 plus R2 times R3. So you're going to take R1 times R2, add that to R2 times R3, add that to R3 times R1, right? It doesn't matter which order you're doing it in, but that's how you get, let me erase this a little bit here and rewrite it again. So we're going to just do the numerator, which is staying the same. So we're going to take R1, R2, and then we're going to take R2, R3, and then we're going to take R3, R1, or R1, R3, depending on which way you want to look at it, but the math, it's the same either way, and that gives you the numerator. Now to divide, if you want to get RC, you look at the resistor directly across from it, R3. So if I was looking for RC, I would divide by R3 because that's the one across it. I don't care what the numbers are, you simply look at the physics. So let's take a look here at a circuit, and we want to do a delta to a Y. So we have values here for the delta. We have these values, but I didn't put any 1s and 2s and 3s and A's and B's and C's in here, right? Because we don't care about that. So if I want to find this resistor value here, and so I guess I do kind of at least need to mark it, but I just can define it when I want, and I don't care what you label those other ones. So if I want to look for this resistor R1, okay, so I'll label it now. This is R1, so I'm going to take these two that it's kind of in parallel with. I say kind of in parallel with. So we multiply, so we're going to take 4 times 6 divided by the sum of all of them. So it's going to be 3 plus 4 plus 6, right? That's the sum of each one. It doesn't matter which order you add them in. And so, of course, 4 times 6 gives us 24, divided by 13, which gives us 1.8462. Ohms, okay, so there's no kilo ohms in anywhere, so that's just ohms. So if we're going to put this in blackboard, the answer would be 1.85, 3 digits, ohms. All right, so now you pick another one. Call this one R2. Like I say, I really don't care what we call it, but we do at least need to give it some kind of label here. But we're going to look these two. So we're going to say 3 times 6 divided by the sum of each of those. So we have 3 times 6, which of course gives us 18 divided by 13. And so that gives us 1.38. Alright, so that gives us 1.38. 46 ohms. And so for blackboard, then that would be 1.38. Okay, down to 3 digits. And then finally, we'll take this one here, which of course I guess I'll call R3. And that one, we're going to take these two resistors, so it's going to be 3 times 4 divided by the 13. And so that would be 12/13. And I can't do that in my head, so I'm just take R3 is equal to 12 divided by 13, and that gives me 0.92308. 0.92308 ohms. And so if we're going to put this in blackboard, remember you must always have a leading zero before a decimal point, and so it'd be 0.923 ohms, or you could put it in milliohms, but I think we'll just leave it in ohms because the other two values are in ohms also. All right, but that is how we do a delta to y. And again, you don't get caught up in ones and twos and R's and C's and A's. Just look at the physics. So we just want to look at the physics there. Now, if we want to do the y to delta, it's kind of the same thing, but again, we're going to set the numerator, and so we're going to set the numerator the same, and so the numerator is this resistor times this resistor, plus this resistor times this resistor, plus this one times this one. So whichever one of the resistors A, B, or C you're trying to get, okay, it doesn't matter what order they're in, you just pick those. And so we're going to set the numerator. So if we call this RA, this one up here, RA, again, the numerator is the same. It doesn't matter. So it's just multiplying them together. So we have 1 times 2, which of course is 2, plus 2 times 3. I guess I'll write them out here. 1 times 2 plus 2 times 3 plus 3 times 1. And there's your numerator. All right, and so that gives us, let's see, we've got 2, 6, and 3. So 3 and 6 is 9, 10, 11. So that gives us 11 in the numerator. And then in the denominator, if you want to find RA, you look to the one opposing it. And so that's going to be 3 ohms. So RA is 11/3 ohms. If we want to find RB, if this one over here is what you're going to call RB, then you look at this one opposing it. And so you're going to have, again, the numerator is not changing, so it's simply 11 divided by 1, which of course is simply 11 ohms. Now, if we're going to put these in Blackboard, we're going to have to do the math, of course. So this would be 11.0 ohms for 3 digits. And this one here, I would actually have to do the division. So 11 divided by 3 would be 3.6667. So for Blackboard, this would be 3.67 ohms. And for RC, if this one's RC, we're going to look across here and divide by 2. So we're going to have 11 divided by 2, which I believe I could do that one in my head, is going to be 5.50 ohms. Alright, so that gives us the Y to delta, or delta to Y, for any possible case. So you just need to look at the physics of it. Like I say, do not get caught up on which one's actually A, B, or C. You just look at the circuit and then you can decide which one you're going to multiply or divide by. Okay? So for going from Y to delta, you look at the Y. Here's at this resistor, and this is the one I'm going to divide by to get that resistor. Okay, so we just need to look at the drawing and we can determine that. Now, if we go back and we look at the original equations here, it doesn't really matter which one of these equations you look at, but if you're going to go from a delta to a Y, so we're going from sort of a parallel sort of connection to a more of a series connection, right? Then if you think about it, if you just have 2 parallel resistors, let's say I had this resistor of 6 ohms in parallel with another 6 ohm resistor, then the equivalent of that, the equivalent resistor that I would put in the middle would end up being half of that, which would be 3 ohms. So I'm going to take, since these are exactly the same, I'm going to take that and divide it by 2. Well, this is a parallel sort of combination. So if you look at this, if you said these resistors are all the same and just call them like R, so you have R divided by R plus R plus R, this gives you, of course, R squared divided by 3R. One of the R's will cancel, so you end up getting R divided by 3. So if you have the case where all your resistances are the same, and you're going from the delta to the Y, you simply divide one of those resistors by 3 to get each of the individual Y resistors. Similarly, if you're going from a Y to delta, you would multiply. So you would take the series one and you would multiply it by 3 if you were going from a Y sort of connection to a delta sort of connection. All right, so very, very simple conversions from delta to Y's or Y's to delta. If you don't get caught up on 1s and 2s and 3s and A's and B's and C's, and simply look at the physics.